Hello and welcome to this video having a look at a level response 6-mark question on the contact process. The question is quite specific in its scope, so we'll try to show you how to navigate around the various ways in which you might be tempted to answer this question whilst keeping track of what it's actually asking you to do. So here's the question, and let's have a look at where it's actually got the instructions down here. So explain the conditions of temperature and pressure could be used to obtain the maximum yield of sulfur trioxide. And it says discuss the importance of a compromise between the equilibrium yield and reaction rate when deciding the operating conditions for the process. So let's think about the subtitles we might want to use for our answer. We've got temperature and pressure in there, obviously, and then we've got the compromise conditions aspect at the bottom. Now, they do tell you that it's carried out in the presence of the vanadium 5-oxide catalyst, but it doesn't say anywhere in the question to discuss that. And when they're talking about compromise between equilibrium yield and reaction rate, they're very specific about what they want you to talk about. It's the yield and the rate, not necessarily things like safety or danger with the high pressure. So let's have a think about what the temperature and pressure aspect might be first of all. Well, you can clearly see that the delta H value is negative, so that means the forward reaction must be endothermic. The low temperature would shift the position of equilibrium to the right hand side, which gives us our sulfur trioxide, so that's favourable. In terms of the pressure, there's less moles of gas on the right hand side. There's 2 moles of sulfur trioxide, and on the left you have 2 moles of sulfur dioxide plus 1 mole of oxygen, so 3 moles on the left, 2 moles on the right. So high pressure will shift the position of equilibrium to the right hand side. Let's think about the compromise now. We've done the first part of the question. A slightly lower temperature than ideal for high yield, but not so low as to adversely affect the rate of reaction. And the pressure itself can be kept high to increase the collision frequency. So that means we've actually talked successfully about the compromise idea between equilibrium yield and reaction rate. So let's now have a look at what we could have talked about. Why not mention a catalyst? And why not mention the expense or danger of high pressure? The catalyst doesn't affect the yield, and you are not asked to discuss it. The actual expense and danger of high pressure don't have relevance to yield or reaction rate, so leave them out. You've been directed specifically to discuss those 2 aspects and nothing else. So looking at the mark scheme, these are the levels. So nowhere does it mention the idea of expense or danger from pressure or the presence of the catalyst. Let's have a look at the indicative scientific points, because that's important as well. So at the bottom you can see that it says ignore references to increasing pressure leading to safety or cost issues. Okay, so hopefully it's been a useful video to take you through how to navigate your way through a specific set of instructions on the level response question, not necessarily just put down all the things you can remember about equilibria and apply them to the sulfur trioxide reaction. Specifically follow the instructions you're given and try to avoid things that you may want to talk about but are not required to. Okay, thanks for listening. Until next time, see you soon.